Good morning, sixth graders. Welcome to today's math lesson. It is your awesome teacher, Mrs. Berg, still doing our distance learning. Hopefully you guys did really well on your quiz yesterday because we're moving into the next part of Unit 7. Today's lesson is Lesson 8, Writing and Graphing Inequalities. You are going to need, of course, your math notes, something to write with, and a highlighter is always good to keep a highlighter or maybe a colored pencil or something close by should I decide to use it today. All right, let's get right into the lesson. So a quick little warm-up since we aren't doing our normal warm-ups, obviously. We're going to do the warm-up provided in today's lesson. We're going to estimate heights of people. So here's a picture of a man. Ta-da! It wants us to name a number in feet that is clearly too high, so that's what we're going to focus on. A number that is clearly too high for this man's height. So again, we're just throwing an estimate out there. I think they say the average man is between 5'10", around 5'10"-ish. So as long as we put any number greater than 5'10", you're going to be A-okay. So let's do it clearly. Let's just say he is 100 feet tall. Impossible, but that's okay. B says name a number in feet, again, that is clearly too low for his height. Well, obviously, it can be any number. Let's just say he's 2 feet. Now it wants us to make an estimate of his height. Okay, well, again, the average chair, usually a chair's height is around 4 feet. I think I mentioned before the average man is about 5'10". If you would stack these two chairs on top of each other, actually it's probably a bit too high. It's probably more like a 3-foot chair. Well, let's just go ahead and say, give him a guess, he's 6 foot tall. Okay, just a quick review on estimation. Real no right or wrong answers. Let's look at number 2. Now we've got a man standing next to a child. It says here if the man's actual height, okay, so now they're telling us he's really 5 feet 10 inches. What can you say about the height of the child in this picture? Okay, well, let's say here again, guys, let's just say, according to the problem, this man is 5 foot 10. And if we were to just kind of draw a line on the boy's height, clearly the boy is greater than half of the length of the man. So we know that, he's going to be taller than half of it. But we can simply say, using today's lesson, well, the boy has to be less than 5 foot 10 inches. And obviously he's taller than our chair up here because of where he strikes the man kind of in chest height. So we can say that the boy is greater than 2 feet. So that's what we said the chair was up here in this example. We said the chair was, we were estimating, we're estimating that too low would be 2 feet. So just fun little estimations. Let's go ahead and turn your page and get to today's actual lesson, okay? Now today's lesson, had we been together in class, I would have given you a whole bunch of cards. But we can't do that online, so we're going to have to just do it on our worksheet here. So we're going to kind of cross out number 1. That was going to be their in-class activity, and let's move on to number 2. Basically, let's highlight these guys. They're going to give us 4 situations. So here's 2A. Come down here, here's 2B. You've got 2C. And on the next page when we turn, we'll get to 2D. So we're going to kind of just be focusing on understanding inequalities, writing them and graphing them. So let's look at 2A here. It says a fishing boat can hold fewer than 9 people. So here's kind of what we're going to focus on, this fewer than 9, and we're talking about people. How many people, and we're going to use the variable x, okay, to represent our people when we write the inequality, can it hold? Well, again, it's saying that fewer than 9, okay? So if we're talking people, that could mean 0, 1 person, 2, 3, 4, 5, 6, 7, 8. hold any people. Now it's not going to hold 9 because it said fewer than 9. If it said 9 and fewer, we would include 9. So we really have to pay attention to what it's asking us and telling us in the description. So there's the people list. Now we're going to plot that on a number line. So we're going to graph it on a number line. We're simply going to graph these numbers on a number line. So let's go ahead and simply put a point at each of the people. Now we know we're not going to be negative numbers because you can't have negative people. So that's why they're all positive numbers on the number line. We're not going to include 9 because it said fewer than 9. So here's the part that's going to be new for you, writing the inequality. Remember, guys, inequality is going to use symbols like greater than, less than, greater than equal to, less than equal to. So these are what we're going to be working with today. Okay, those are inequality symbols. There's 4 of them. All right, so now we're going to graph this. Now we're going to write the inequality based upon our number line. So we're simply going to say that x, remember x is the people, has to be less than 9. Okay, it's not going to include 9. It's going to be less than 9. This inequality here, guys, represents this number line and answers this question up here. Okay, that's what we're doing today. Okay, let's move on to number B because they're all going to be a little different. Lynn needs more than 9 ounces. Oops, I kind of wrote over that. Here's what we're going to do. More than 9 ounces of butter to make cookies for her party. How many ounces of butter, here's our variable again, x, would be enough? So if we're doing more than 9, that means anything greater than 9. And we're talking ounces. So it could be any rational number. It could be 9.5, 9 3/4, 9 1/4, anything like that. So what we're gonna describe, okay, and we're simply gonna say any value greater than 9, including all rational positive numbers. Okay? Rational numbers, remember we talked about this? That includes decimals, that includes fractions, it includes mixed numbers, improper fractions, any of those, okay, you can use. Because again, when you're cooking, it's not always even numbers, right? Now let's go ahead and graph our description on the number line. So it's going to be any value greater than 9, including all rational positive numbers. So here's something you've probably never done before. Instead of putting a closed dot at 9, we have to put an open dot at 9. Okay? Because it's not going to include the number 9, but it's going to include all numbers. So we have to darken, yep, believe it or not, that's what we're doing, darkening that number line and then putting an arrow at the end. This tells us it's not going to include 9, but it's going to include all positive rational numbers greater than 9. This would just keep going and going and going. So let's pause here and just make a very important little note. An open dot means it does not, this is very important that you understand this concept, does not include the number. Okay, believe it or not, this is a pretty big deal in today's lesson. If it's open, it doesn't include it. If it's closed, it does include it. We think that's the next one. So now let's write the inequality expression, okay, that matches this line. Basically, it's telling us that butter, which is x, in ounces is going to be greater than the number 9. We use the greater than symbol because it's an open dot. If this was a closed dot, we'd use the greater than or equal to symbol, this one up here, which I think is in the next problem, something similar to that. So, speaking of the next problem, let's move on. A magician will perform her magic tricks if there are at least 9 people in the audience. Again, we're talking people, and here's the key, at least 9 people. Okay, so she can have 9 or more people. She has to have at least 9, so we're going to include 9. So the description list would be 9. She could have 10 people, 11 people, 12 people, and this could just keep going and going. Okay? Let's graph this description or this list of numbers on our number line. Now, because we're including 9, we're going to put a closed dot. Now, these are people. We can't have fractions of people or decimal people. We can only have whole numbers, right? So we have to then put dots on each of the, we'll just go all the way to the end of our number line, and then we'll put an arrow because it's going to continue. We're not going to do what we did up here. This up here tells us it includes any fractions or decimals because we're talking people. So they're just going to be solid dots on the number line. Again, notice how we put a closed dot, guys. This is important. So write this down in your notes. A closed dot means it does include the number. Okay? It's that, this is very important to the lesson today. Okay, let's write the inequality. Again, we've got, it's going to include 9 and all the other numbers. So, x is our people. X is going to be greater than or equal to 9. Here's that inequality symbol. Okay, greater than or equal to. This is what goes with closed dots. You have to have this little line. It's very important. Okay? Let's do the last problem for this little graphing activity here. So turn your page. Okay, this is D. A food scale can measure up to 9 kilograms. Okay, this is what we're talking about here. Up to 9. The weight is going to be X. Okay? Make a description or a list. Well, it's going to be up to 9. Okay, that means it can include all numbers, all rational numbers, all the way up to the number 9. So we're just going to say, because it's all numbers, I'm not going to write all the numbers, because it would include fractions and decimals and so on and so forth. I'm just going to say then, any value from 0 through 9. And again, these are going to be all rational positive numbers. Okay, here's our number line. It's going to be all numbers 0 to 9. So we're going to put a dot at 0. We're going to put a dot at 9. And we're going to darken in that number line. This shows us that it's all numbers in between 0 and 9. Okay, again, we've got a closed dot because it includes 9, and it does not go past 0 because you can't have negative weight, so it's going to stop at 0. So it's kind of like we just drew a line segment. Inequality. Well, there's kind of 2 here because it has an end and a start. So it's going to have to be, X is going to have to be greater than or equal to 0, and X has to be less than or equal to 9. This part describes this point. This inequality describes this point. Okay? So that's how we do that. Let's look at 8.3. Here's a picture of a person and a basketball hoop and a ladder. Based on the picture, we're doing some estimating. What are the reasonable estimates for maximum and minimum heights of the basketball hoop? So we're going to be talking about the basketball hoop. Complete the first sentence in the blank with an estimate and the second blank with taller or shorter than. Well, let's read this. I estimate the minimum height of a basketball hoop to be, okay, well, basketball hoops are pretty tall. I mean, the average lady is about 5.6 inches. So let's just say the minimum, so I'm looking at the minimum height of a basketball hoop might be 8 feet. could be taller. Okay, this means the hoop cannot be shorter than 8 feet. Okay, so maybe if it's dropped down low, sometimes you drop the basketball hoop down low for little kids, move it up high for older kids. B says I'm going to estimate the maximum height to be 12 feet. This means the hoop cannot be taller than this height. So basically what we're saying here, guys, is the maximum height of the basketball hoop is going to be 12 feet, and the lowest it can be is 8 feet. Okay? Write 2 inequalities, 2 ones, to show your estimate. So we're going to write one for the minimum height, and we're going to write an inequality for the maximum height. So based upon what we just set up here, we said that, and I think it tells us the variables, the variable is going to be h. So if we do the minimum height one, we're saying that h, the height of the hoop, has to be greater than or equal to 8 feet. Okay, that was as short as it can be. So it cannot be any shorter than 8 feet. So it's going to be greater than equal to 8. Then for the taller height, we said that h has to be less than or equal to 12 feet. That's all you're doing there. Flip it over. Okay, now we're going to plot these on the number line. So again, we said the minimum h was going to be greater than or equal to 8 feet. And we said the maximum h less than or equal to 12 feet. Okay, so now we're going to practice graphing these. Okay, we've got closed dots, guys, because these include the numbers. Okay, so they're not labeled, so let's just quickly label our number lines. Here's 8. It's a closed dot. And the height can be anything greater than 8. Let's graph this inequality. Again, let's quickly write our numbers on our number line. I don't know why they didn't do this for us, but that's okay. We'll stop at 12. This inequality is saying that h is going to be less than or equal to. And we'll darken in the number line. Okay, that's all you have to do there. Just practice graphing. That's all we're doing. Okay. So suppose a class, number 4, suppose a classmate estimates the value of the height to be 19 feet. It's a really tall basketball hoop. Does this estimate agree with your inequality for maximum height? Okay, so does 19 feet, if h equals 19, okay, does that match with this? Well, no, it doesn't, because we're saying h is less than 12. So this first question it's posing, no, it cannot be greater than 12. Second part of the question says, does it agree with your inequality for the minimum height? Explain or show. Well, our minimum inequality, we said the height could be greater than or equal to 8. Well, 19 is greater than 8. So for this one, we would simply say, yes, it can be greater than 8. Okay, and we're going to do Are You Ready for More? Because guess what? It's really not that hard. Oh, we're not doing 5. Cross out 5. Not doing 5. That's a partner. We don't have partners today. Okay, we'll do Are You Ready for More? Because it's pretty quick. It says find 3 different numbers that A could be if the absolute value of A is less than 5. Plot these points in the number line. Okay, then plot as many other possibilities for A as you can. So A is less than 5. So we're going to find positive 5 on the number line. Okay, it doesn't include 5, so we'll have an open dot at 5. Now remember, absolute value, guys, these are negative and positive numbers. So this A could really be a positive 5. This A could also be a negative 5. Okay, absolute value. It's distance away from 0. So you can come down here then, if this is the case, and also put an open dot at negative 5. Then any of these numbers between the two could be a possible solution. We're just going to fill them in. Okay? Any of those. 2, similar problem. This time it's saying b is greater than 3. Okay? B is an absolute value. Okay? And it can be greater than 3. It's not going to include 3, but greater than 3. So we're going to find 3 on the number line. It's going to be an open dot because it doesn't include it. And it's any number greater than. Okay? So now we're going to be going to the right. Come down here to our negative 3, since it's absolute value, open dot, and the same thing, darken up. It could be any of these numbers. Okay, that's how we would read absolute value. All right? Okay, that is today's lesson. So it is now homework time. Ta-da! Okay, so you're going to pause this video. You're going to go to Google Classroom for today's math lesson, and you're going to open up today's math worksheet, okay? Which is this one right here, Unit 7, Lesson 8, Writing and Graphing Inequalities. And you're going to complete all the problems, and then when you're done, come back to the video, and we will be going over the answers, okay? Okay, welcome back, guys. Okay, hopefully you have your homework completed. Remember, you're doing your homework on a lined piece of notebook paper. You should have put your name and your number in the upper right-hand corner. And on the top line, you should have written Unit 7, Lesson 8. Again, I will be collecting these, okay, when we return to school. So you have to be saving them and keeping them very organized somewhere in your binder or in a safe place at home. All right? You should have written down all your answers, okay, showing work where needed on your lined paper. I'm going to go through the homework sheet now, and we're going to make sure that you did, in fact, get the right answers. I'm actually going to go through it. So this is a chance for you to check your work, and if you got a wrong answer, just like we do at school, you may not have a red pen, but you should be correcting your own work. So this first problem says, at the book sale, all books cost less than $5. So what is the most expensive book? Hopefully you put, well, $4.99. If you got that right, give yourself a star. If you got it wrong, write the correct answer. Write an inequality to represent the cost of books at the sale. Okay, well, let's just say that C is the cost of the books. So all the books are going to cost less than $5. Doesn't include $5 because it says up here it costs less than 5. So we use the less than symbol. Draw a number line to represent the inequality. Okay, here's your number line. We're talking about books that cost less than $5. Let's just do 1 to 5. It's not going to be any negative numbers because books aren't going to cost negative. Okay, it's less than 5, so you should have put an open dot because it's not going to include the $5, but it's going to include any prices less than $5. So darken in that number line and then put an ending dot at 0 because it's not going to go past a 0 book price. There could be some free books there. You never know. Okay. Number 2, Kieran started his homework before 7 p.m. Okay, so before 7 p.m. He finished after 8 p.m. Let H represent the number of hours Kieran worked. So if you started before and he finished after, we know he worked more than an hour, okay, because it was before 7 and after 8 is when he finished. Okay, he didn't start at 7 and end at 8, which would be an hour. So he definitely worked a little more. We just don't know when he ended or when he specifically started. So let's just say you should have either written definitely true, definitely not true, or possibly true. H hours greater than 1. Well, we just talked about that. He definitely worked on his homework more than 1 hour. So this is definitely true. Number 2, he worked on his homework greater than 2 hours. Well, this would be a possibly. We know he worked on it 1 hour, but we don't really know, was it 1.5? Was it greater than 2? So this could be a possible answer. C is hours were less than 1. Okay, this is definitely not true because we know he worked at least more than 1 hour. So this is definitely not true. And H is less than 2 hours. This would be a possibly true. Maybe he only worked at it for an hour and a half or hour and 15 minutes. Okay, so that could be a possibly true. Now the next problems, guys, are all review problems. So you should have been able to do these. Here's a cube. I gave you the formula for volume. Write an expression to find the volume. Well, volume is length times width times height. So, couple choices. Okay, you could have done 4 times D times D. Okay, 4 times D times D. You could have done 4 times D squared. Okay, because you have 2 D's there, so we could simplify it to 4 times D squared. You can even have done 4D squared. Okay, so this is simplification of this. So any 3 of those would be the correct way you could write an expression. So in the part B, we're going to use this most simplified expression to solve when the volume is, when D is 1, D is 2, D is 1/2. So you should have just plugged these numbers into this formula to get your answer. Okay, so for this one here, when D is 1, you should have put 4 times 1 squared. Okay, we know that 1 squared is simply 1 times 1, which means this is really 4 times 1, which is simply 4. Okay, what about when D is 2? Well, 4 times 2 squared. Hopefully you remember that 2 squared is 2 times 2. So this is like 4 times 2 times 2. Which is 4 times 4, which is 16. Okay. What about when D is 1.5? Okay, well, 4 times 1/2 squared. That's the same as saying 4 times 1/2 times 1/2, which is 4 times 1/4, which is 1. So hopefully you get those correct. Next page. This is something kind of what we had a couple days ago. You have to match up the statement with the right inequality. Okay? And it really means closely reading, okay, the words. So for number 1 here, I said the number -15 is further away from. That means we're talking absolute value when we're talking distance away from. So we're going to be looking for problems that have the absolute value symbol. Then the number -12 on the number line. So you come over here. I'm going to look for a problem that has the absolute value of -15. Okay, which is going to be further away from. Okay, so it means it's going to be greater than number 12, and it belongs to C. That was probably the hardest of all of these, actually. I don't know why they put the hardest one first. I wish they had put that last. Okay, I'm going to come down here now and start at the bottom, because I personally think it's easy and then it gets harder. So number 6, the number 12 is greater than the number -12. So this is a simple inequality. It's the greater than symbol. So I'm going to come over here, and I'm going to find the one that shows that 12 is greater than -12, and it's going to be E. Not talking absolute values, just talking strictly numbers. 5, the number 15 is going to be less than the number 12. Again, we're just talking numbers. Let's find where it says 15. Oh, that's B. Okay, so B is 5. Number 4. The rest of these are all using some type of absolute value. The numbers 12 and -12 are the same distance. Okay, well, that would mean we're using the equal sign from 0. Okay, the numbers 12 and -12. So I'm looking and I see right here is F. Again, if we're talking same distance, I'm using absolute value symbols. So 4 belongs down here. Okay, D belongs with number 2, and A belongs with number 3. Number 5, last problem. Here are 5 sums. Use the distributive property to write each sum as a product of 2 factors. Okay, we did this, this was way back, this is just the last unit 6. So in this one, I look for what's similar between the 2 numbers. And I see that A is similar. So I'm going to pull out the A and then put the 2 plus 7 inside the parentheses. You could also do A plus, could also add 2 and 7 together to get A as 9. You could even do 9A. Any 3 of those would be acceptable. 5, again, no common variables, but I can pull out a common factor of 5 and 10, which is 5. Pull that out front, and then Z minus 2 is left inside. And you can check it by saying 5Z times Z is 5Z, minus 5 times 2 is 10. Real easy to check these. C, I see a C is common, so I'm going to pull out the C. And inside the parentheses is 1 minus 2C. Okay, you can check your work there. D, I have 4 R's in a row, so this is simply 4R. E, this one's probably the hardest of the bunch. You've got a 2 and a 1/2. So I'm going to pull out the 1/2, okay, and put that out front. So inside the parentheses is 4x minus 1. Again, I can check it by saying 1/2 of 4x is 2x, and then 1/2 times 1 is 1/2. Or you could pull out the 2 and have x minus 1/4. Okay, anyways, that's your homework. Hopefully you guys did really well. Remember, save it. Keep it in a safe place, and we'll see you tomorrow. Bye.